Hello and welcome to this section of the MATLAB tutor. Here we're going to continue working with matrices and learn how to add them, how to subtract them, and how to multiply them by a scalar. And if you haven't already, you really should watch all the lessons on vectors that we did several sections ago, because most of this matrix stuff is sort of a direct extension of that. So go and look at those if you haven't already. So adding and subtracting matrices is very straightforward. So let's just do enter a couple of quick matrices in to see how it works. We'll create matrix 1 equals, open bracket. Let's make it a 3 by 4 matrix. So we'll do 3 rows and 4 columns. So this is the first row. This is the second row. What did I say? 3 rows and 4 columns. So we'll do, -4, 0, -1, -2. So that'll be our third row. So there's the first row, there's the second row, there's the third row. There's my matrix, and I'm going to edit this basically, call it matrix 2, and the next one we'll just to make it easy, just to make sure there's no overlap. Let's do it like this. Let's create a matrix. Let's do something crazy. Let's create a matrix of all ones. 1, 1, 1, 1, semicolon. Let's do the next row. Let's do 2s. 2, 2, 2, 2. And then we'll do 3, 3, 3, 3. So that's a pretty simple matrix to create. And that is unbalanced. Look what I did at the end there. I have an extra bracket. So MATLAB will try to tell you when you did something wrong. And so there's my matrix 2. So here I have, let me clear it out, matrix 1, matrix 2. So these are the two matrices that I created, all right? So if you want to add these matrices together, it's just as simple, matrix 1 plus matrix 2. And so what's going to happen when we hit enter is we're going to get another matrix back. That's going to be the sum of these two matrices. Now, for those of you who have studied matrices, which is probably everybody watching this video, the only way you can really add matrices together is if they're exactly the same dimensions. That means matrix 1 has 3 rows and 4 columns. Matrix 2 has 3 rows and 4 columns. So when they match exactly, when you add a matrix to another matrix, what you're doing is you're adding elements. So the first element in the first row in the first column is added to the first element in the first row in the first column there. So 2 plus 1 is 3. So this guy is going to be added to this guy, giving you 4, and so on. 4 and 1 is 5. And if you go down to the bottom of the matrix, this one plus this one is going to give you a positive 1. This one plus this one is going to give you positive 2, and so on. So it's going element by element and just adding them together. Now, you can subtract these guys as well, and exactly the same thing happens. You're taking matrix 1, and you're subtracting from it matrix 2. So 2 minus 1 is 1. If you go down here where you have 0, 0 minus 3 gives us -3. So it's going element by element, and it's adding these guys together. Now let me clear the screen, and let me create matrix 3. And I'll set this equal to 3 space 4 space 5. 4, 4, 4, 0, 1, 2, like this. Okay, so there's matrix 3. So let me clear the screen. So let me show you matrix 1 and matrix 3. So these matrices look different, right? I mean, this guy has 3 rows and 4 columns. This guy has 3 rows and 3 columns. Do you think you're going to be able to add these together? Well, let's see what MATLAB says. Plus matrix 3. So we try to add them together, and MATLAB says error using addition. That's what that means. Matrix dimensions must agree. So it's unable to add these together because they don't match. The shape of the matrices don't look the same. So it has to have the same number of rows and the same number of columns. And if it doesn't, then you're not able to add them. And that's not a MATLAB thing. That's a mathematical thing. You can't add them by hand. You can't just add these elements to these elements here and just forget about the fourth column. You just can't do that. So they have to agree if you're going to add them or subtract them. So that's adding and subtracting matrices. Now multiplying matrices by a scalar is very simple. We've already done that before. So let's pull up matrix 1. If I wanted to multiply matrix 1 by 5, I'll just literally type in 5 times matrix 1. And what it's going to do is multiply, again, every element by element, by the number 5. It's kind of like distributing the number 5 into each element. So 5 times 2 is 10. Down here, 5 times -4 is -20. Over here, 5 times 6 is 30, and so on. And it obviously doesn't matter if you do 5 times matrix 1 or matrix 1 times 5. It's the same thing. It doesn't matter. It's just like 3 times 4 is the same as 4 times 3, so you can enter it any way you want. You can also multiply by any constants. You know, pi times matrix 1 is going to work out. Remember, the matrix 3 that we created was a slightly different shape, so it works for whatever shape you have. Pi times matrix 3, so it's going to take 3.14 and so on, and multiply by each of the elements in there. So anytime you're multiplying by a number, whether it's a regular whole number or something like pi, it's just distributing it in. Now the same thing holds true of imaginary numbers. If I want to take I times matrix 2, it's going to multiply the imaginary number I times every element in matrix 2. And so if you pull up matrix 2, this is what we originally had. So 1 times I gives us I, and everything is the same here. 2 times I is 2I, and so on. So multiplying by a scalar, even when that scalar is a complex number, or in this case it was just a pure imaginary number, is fine. In fact, you can even get a little bit more crazy. Let's just wrap a parentheses around this so we make sure we do it right. 2 minus 3I times matrix 3. So this is what we call, a complex number. It has a real part and has an imaginary part. There, we can multiply that by a matrix, no problem. MATLAB's going to distribute this complex number into each element. And let's just pull up matrix 3 so you can see for reference. So for this guy, we have 3 times 2 minus 3i is going to give you 6 minus 9i. And so it's basically doing it exactly as you would do it by hand. Now, of course, we can, combine these things together. So I can do, instead of this guy, I can multiply it times, and then instead of matrix 3, I'll do matrix 1 plus matrix 2 minus 2 times matrix, 2. I know it's a little silly, but basically what's happening here is I take matrix 1 and I'm adding it to matrix 2, and then I'm subtracting 2 times matrix 1. This is a scalar, right? So what's going to end up happening is the 2 times the matrix is going to happen. And we've already done that sort of separately. So we're going to get a new matrix there, and then I'm going to do this addition and subtraction kind of in sequence, just like order of operations. This is going to give me a matrix on the inside, and then I'm going to multiply by everything on the outside there, and so MATLAB handles that just fine. Of course, all the answers are complex because I see it here. And for some reason, if this is hard for you to read, if these complex numbers are difficult for you to read, you can just go over here. The last answer is what was just calculated. That's always stored here as the last answer. You can double click it, and then you can go over here and read everything if you need to space things out. Maybe you have a giant matrix, maybe it's 50 elements long or something like that. So I hope you've enjoyed this section. Make sure you understand how to add and subtract matrices. The main thing is they have to be the same size. If they're not the same size, the same dimensions, it's not going to work. You can multiply matrices by scalar numbers, complex numbers, pure imaginary numbers, irrational numbers like pi, and it's all just fine. Here in the next couple sections, we'll learn about how to multiply matrices times other matrices, which is an important topic all by itself.